Okay, so far with functions, we've talked about the domain of the function, which is all the x values, and the range of the function, which is the set of y values. The domain, we want to look from left to right, and for the range, we want to look from the bottom to the top. Remember that we use square brackets if the graph touches a value, and we'll use parentheses when the graph does not touch that value, including infinities. Today we're going to get more detailed about domain. We're going to talk about intervals of increase and decrease, and these are parts of the domain. So when we're giving intervals of increase, since these are parts of the domain, they will always be x values. All right, for increasing, we'll say that the graph is increasing when the right side is higher than the value on the left. So for a part that looks like this. We'll say the graph is decreasing when the value on the right is lower than the value on the left. And we'll say the graph is constant when the value does not change. We will write these intervals in open intervals, meaning we will always use parentheses because the endpoints are not part of the increase or decrease. So we leave them out by putting parentheses. Okay, so here's our first example. And before we start this with intervals, let's take a chance to say the domain and range of this. So domain, remember, goes from left to right. So on the left side of the graph, we're at x equals -5, and there's an open circle. So we'll have a -5 with a parenthesis for the open circle. On the right side of the graph, we have x equals +5, and there's a closed circle. So we'll put a +5 and a square bracket for the closed circle. Okay, and now range. Range is the y values. It goes from the bottom of the graph which is at -2. Now this is tricky because there's an open circle right there, so you might be tempted to use parentheses, but it's equal to -2 here, and it's equal to -2 there, so we're actually going to use a square bracket. The top of the graph is at +2, and it equals it for quite some time. So 2 and square bracket. All right, so now let's get more detailed. Let's check out when is the graph increasing. So we want to find every interval in which the value on the left is lower than the value on the right side of the interval. Okay, the first place to point out would be right here, and then the second place would be over here. So remember, these are supposed to be x values. They're all pieces of the domain, so we want to look from the left side to the right side of that interval. So from x equals -5 to x equals -3, the graph is increasing. When we're giving intervals for increasing, we never include the endpoints. So parenthesis, parenthesis. Okay, the other part is over here, this area. Okay, so from the left side to the right side, from x equals 3 to 4, the graph is also increasing. And again, we don't include the endpoints, so parentheses. So these two parts of the domain have an increasing graph. Okay, now let's find the areas where the graph is decreasing. When you're decreasing, the value on the left is higher than the value on the right. This would be one area of decrease, and then over here would be the other one. So again, from the left side to the right side, same as you do with domain. So from 0 to 2, do not include the endpoints, so parentheses. And then again from 4 to 5. Don't include the endpoints, so parentheses. Lastly, where is the graph constant, meaning not changing in value? There's two places, right here at its peak and down here at its bottom point. You might be tempted to give the y values, but remember these are parts of the domain. So we want to record from the left to the right. So from -3 until 0, parentheses, and then again from 2 until 3. So these are the two intervals where the graph is constant. Okay, so here's our quadratic. Remember, there's arrows on the end like we studied last unit. Let's do the domain and the range for this. Remember, domain, all x values from left to right. We have an arrow on both sides, so we would have -infinity to +infinity. It's impossible to touch infinity, so parentheses. For the range, we go from the bottom to the top. At the bottom, we have a point. We have a point at +3, and it's touching it, so bracket. At the top, we have the arrows, and the arrows represent infinity, in this case, the positive direction, and you can't touch infinity, so parentheses. All right, on this graph, we have a quadratic equation. Remember from our study of functions that this continues on forever, even though the graph program did not put arrows on it for us. These are a little tougher because it's not immediately obvious where the intervals start and stop because there's no points. So you want to trace along the graph and look for changes of direction. So the graph is starting here and it's descending. Then it hits the vertex and then the direction changes. Then it's heading up. So that vertex point is where our interval will stop. We'll have one interval on the left and a different interval on the right. So, on the left, we're starting up high on the left and lower on the right. So that is decreasing. And on the right, we're starting at the bottom, we end up higher. So on the right, we will be increasing. Okay, so let's give the values. On the left, we have an arrow. It's on the left side of the graph, so negative infinity until the interval ends at 0. On the right side of the graph, we begin at 0 and continue on to the arrow, so positive infinity. Again, never include the endpoints, so intervals are always in parentheses. This graph, a quadratic equation, a parabola, has no constant interval. So we're not ignoring it, there just isn't one on this.